sunset of our love, and we can't turn back. If only I had let it go before I got caught up in the trap. I thought we were on the right track. Broken promises, kept between.
So our next presenter is going to be Jorge Alejandre, and he is advised by Dr. Gary Holness, and his talk is entitled Translating American Sign Language with the Help of Computer Vision. So I'm going to give him presentation powers. And George, you should be able to unmute.
Yeah, I can. There's a question in the chat for Gyro, I believe. There's a question in the chat for Gyro.
Gyro, which software? Yeah, I see it.
Yeah, I use
so
the
can you which software you using to for developing the app?
Android Studio.
Okay, Android Studio. Yes.
Yeah.
Okay, thank you. Okay. George, you have presentation powers. You should be able to. Yeah, good.
Okay. All right, hello everybody. So this is my project for my capstone. So I worked on an American Sign Language translator. So, okay. So it is estimated that around 98 million Americans suffer some form of hearing loss, with about 2 million of those people are completely deaf. So what I wanted to do was I wanted to create a solution that would benefit all of those people. So not necessarily the people who are deaf, but I want to help the people that are around the people that are deaf, because around 96, 98% of people do not have any kind of education in sign language. So it's kind of difficult for people to understand people who are deaf if they don't know how to communicate with them. And like around 72% of families don't even sign with their own children. So you can see how that can be a huge issue in the community, and for the people who are deaf, it really affects their quality of life. And I just want to create a solution for them that isn't very expensive, because we can look at some of the current world applications at the moment. So UCLA is actually working on wearable tech gloves. So you put the gloves on, and when you sign, it translates whatever you're doing in real time. And so it looks like it works and it's a really good application, but considering you have to wear gloves and it has a lot of different sensors on it, it's most likely really expensive. And if people don't even take the time to learn it, they're probably not gonna make the effort to try and afford or be able to pay for those gloves. Other places such as Paichi University work on feature extraction with the use of the convex detection, or the convex defect detection algorithm. And so I kind of took parts of that and incorporated in mine. I also did a little bit of neural networks using TensorFlow, and I will talk a little bit on that later. And then there's also companies such as SignAll who work on actual software and applications. So you can make an account with them. I think they just started this year. Um, they actually released all their software, and so you can actually take the time to learn on their website and stuff like that, and take courses for them as well. Um, so for my portion of the project, this is kind of the algorithm or the architecture that I used. So for mine, I just have cameras. I don't have sensors. So I just have one camera that will record a video. And so this is kind of the approach that I had at the very beginning. I eventually, as I went on, I ended up changing some of it. So the first portion of it was image segmentation. So what image segmentation is, like the partitioning of the digital image. So I would take in so I would take in the recording, and I would press a button and it would take a picture. So when it takes a picture, I had a colored glove, and so I would extract all of the yellow particles in the or yellow pixels inside of the image, and it would change the channels from BGR to HSV, and then it would find the threshold and just create this mask. So it eliminated everything in the back, and it would just keep the glove itself. So I wanted to do this and pass it on to the next portion, which was the skeleton extraction. And so what the skeleton extraction is, it's just a mathematical description of the state of your hand. So different points are planted on your hand throughout the joints, and these are kind of what signify all of your, like the bones, and they're just there to make sure that you have the right positions of your fingers to be considered a proper gesture. And the proper gestures are stored whether in a database or a file. So for my case, they were stored in a file. And there's also some parts of the algorithm that find the line. So it just connects the hand throughout all the joints. And so basically for mine, what I did was I kind of eliminated the image segmentation portion, and all I wanted to do was the skeleton extraction, because with the image segmentation, I ended up taking pictures and stuff. So with the skeleton extraction, I just ended up doing it in real time. And so the next portion of it came was the gesture recognition. And so what that is what it's a topic with the goal of recognizing like actual hand gestures when you move your hands. And to do that, you have to clarify certain directions, and then you have to have a certain confidence with it. So for my case, each finger would have a specific point value, and when you sum up all those point values, it would give you an ultimate or a final confidence. And so the gestures that I wanted to recognize were at first just letters because they are still images. And then later on, I wanted to focus on actual moving gestures. And I kind of had some issues with the moving gestures. So I kind of just, for now, focused on letters. And so I did my gesture recognition using TensorFlow. And so TensorFlow is a framework used for building deep networks. And so what happens in TensorFlow or in any neural network, you input image pixels. And so starting from the very bottom, each layer will compute a nonlinear function over a weighted sum of inputs. And each layer will add on to the one before it, and each layer will combine simple features to form shapes. So with every single layer, you keep getting closer and closer to what you actually want. And so you start off with very simple features and you just keep expanding and adding onto it. And ultimately you get whatever you want at the end. So you can get like a hand or a face or your body. And so for mine, it was just the fingers. And I ended up with finger descriptions, and I'll touch a little bit on it. So here I have some of different positions that your hand can be in and some of the different directions that I implemented. And so I have in the first image, you see my hand has absolutely no curl, and the 1.0 is to show that like it has to be strict on that. And so it'll give you an entire point if your fingers are all the way out. And as you see, the hands are vertically up. Here I put zero point 0.5 because the thumb is kind of up, kind of to the side. So I give it a little bit of leeway on that. The one with that looks like a C, they are half curled, and you kind of want to make sure that it's not a full curl, but also not a no curl. So you kind of you want it to be sure that it's a half curl. And so you add in all the directions, and same with the last one. And the last one I had to create two different kind of directions because the first or the four fingers that aren't the thumb, they are in a different direction because they are vertically down while the thumb is out to the side. And so there are sometimes instances where you have to talk about different fingers because they all look different. And so then finally came the visualization. And so what I wanted to do was I will have the hand, and so whatever finger or whatever letter I am displaying, I want it to show on the screen. And so that's kind of what I wanted to do. And so here's my demo. So this is just for the letter, because I didn't manage to implement one gesture, but it wasn't accurate yet. So as you see here, I'm showing the different letters in the alphabet. Um, and so over here is a console where I log all of the information about the letters. And so in a minute, I think it's going to show the confidence or one of the examples of an array. So each letter can, or each gesture can have similarities to others, but ultimately it just gives the one with the best confidence. And that's the one that's going to be displayed up on the screen. And then this was my, then this was my gesture demo. So for the gesture demo, I implemented the letter J because the letter J is a scooping gesture. And so what I did here, I kind of, since it's the exact same thing as an I kind of did like a middle and then like an end kind of like ending. So I kind of described what it would look like at the end and kind of what it would this look like in the middle. And so it's just going to be like a switch on and off between the I and the J. So I would have to work on certain aspects of the algorithm to make sure that I can detect certain gestures differently. Because so I didn't end up implementing all the letters because once I added more and more letters, it became very confusing for the detection because some letters are very similar. So like this is an N while this is an M. So like it's just very simple movements of your thumb and stuff. So the algorithm would have a hard time distinguishing between certain letters. So I may have to go in and maybe add some more directions or even take away some directions for certain letters, some that may not be so important. And then I also might want to work on the confidence levels. So I may have to add a higher confidence, maybe not just 5 or 6. So creating more directions would add in more confidence and make sure that the right letter is being displayed. And so this is just a project that I plan on continuing to work on. And so this was just kind of the first part of it, trying to work on the actual detection. But I do want to make it an app that will eventually help people take it upon themselves to really learn sign language and be able to sign with the people around them. So thank you everyone for joining me, listening to my presentation.
Thank you. Thank you, George. Thank you, George. Okay, any questions, please? You are welcome to unmute and ask or type it.
A question. Yeah.
Go ahead.
Can you hear me?
Yes.
Yes.
Yeah, this was a very awesome presentation and a very wonderful research. Now, my question is, are there deviations to maybe gestures or hand positions through which the app or what could be able to recognize now in the interpretation? So what I mean by that is that now there are some times whereby there could be some irregularities of gestures. So are there like a bandwidth, a space of recognition of translation to say, okay, actually, in case the movement of the hand or the finger deviates from what is supposed to be, the software could you also be able to recognize those irregularities? I don't know whether you understand my question.
Yeah. So I do. So right now, when I define my gestures, so because basically what I did, I have files for each different letter, and so I kind of explain how it's supposed to look. So like I mentioned in one of my slides, here what I did when I define the descriptions, most of the time I do give it leeway, but there are times certain directions have to be exact. So when I give it leeway, it's kind of making sure that I can detect those like informalities. Like if something seems to be a little off, it should still be able to recognize it. It may not always be completely perfect, but it should be able to detect like the small little differences. And so hopefully, yes. I also do plan on implementing something where like when you sign something, instead of just going straight to one answer, I hope that it will, or I wanted to display three different options and for you to be able to select the right one in case you want to say something specific. Because like I said, there are some that are very similar. And so it may not always accurately display what you want to say. So yes.
Okay, yeah, thank you very much for that. My second question is this. Now, there is, what I call it, standard, what standard of sign language? The development, is it based on the world standard or maybe as defined by the United States, or does it require a sort of training as you define it, so that it will help the contemporary person that lack the understanding to at least flow with it? So I don't know whether are there basics of reference that define these gestures by the hand. I don't know whether you also get what I'm trying to say.
Um, Not sure. By
Okay. What?
standard, do you mean like, is it also, I kind of just did it for American Sign Language.
Okay, from American Sign Language that is generally accepted, right?
Yeah.
Okay. Thank you.
Okay, thank you. Thank you for the questions too. Great job. Thanks, George. Our next speaker, I'm going to superpowers. All right, I think you're good to go. All right, so the next presenter is Komlan Atiogbe, and his advisor is Dr. Gary Holness, and he's going to be talking, his title of his talk is Algo Access. Take it away, Komlan.
Okay, cool. Sharing that screen. All right, my name's Komlan Achobi. My advisor is Dr. Gary Holness, and here's Algo Access. So, some of us know what happened with GameStop recently, and there was a large hedge fund with a significant short position. So, when you short a stock, the idea is that you borrow the stock, sell what you borrowed, and then buy the stock back with your potential profits in order to return it to the lender. Short sellers are betting that the stock they are shorting will fall in price because the difference between the price at which the stock is borrowed for and the price at which the stock is sold for after it falls is their profit. Now, stock prices change every day by market forces, and by this I mean that share prices change because of supply and demand. If more people want to buy a stock, the demand, then they want to sell it, the supply, the price will go up. This is exactly what was done with the help of Wall Street bets, where they all banded together and decided to buy GameStop and cause the price to move up. This is known as a short squeeze, and this occurs when a stock or other assets jump sharply higher, forcing traders who had bet that its price would fall to buy it in order to forestall even greater loss. So now the hedge funds are buying more GME stock, trying to save themselves, and people in Wall Street bets are also buying more GME stock, which is increasing demand and also increasing the price of the stock. So you might wonder why big investors or hedge funds would have taken such a large position on GameStop. And that's because big investors and hedge funds have a lot of tools at their disposal to help them make trading decisions. There are a plethora of trading algorithms out there, and some are based purely on math, some based on market activity and news, and some that are a combination of these elements. These trading algorithms are not something that you can find online, and it is a closely guarded secret at all these hedge funds. Along with these hedge funds, they have quantitative traders to help them out. A quant is someone who will use mathematical models and other sources of information to make trading decisions. And this is such a highly valued job that it's not uncommon for the base salary to be $250K a year. And a hedge fund can have a whole department of quants to help them out. And then there's also insider information which is available to them. Once you reach a certain wealth status, you just gain access to information that a regular person simply would never hear until it's too late. So, disregarding the question of morality and ethics when considering what large investors and hedge funds do, I wanted to implement their trading methods for the small investor in order to help make you money. So, I wanted to have trading algorithm in the palm of your hand, different levels of trading for beginner, intermediate, or expert traders. And I want the decisions to be made purely on statistics in order to eliminate any emotional trading. So we I want to make a phone app that is easy to navigate and use. There are a few apps in the App Store right now that have the same idea, but they have a low amount of downloads, and the reviews state how difficult it is to use the app. And I'm also doing it purely based off mathematical decisions and making it affordable, because I'm sure that not everyone in here has the means to pay $250,000 a year for an analyst to help you manage your portfolio, or to have a hedge fund take a percentage of your profits for using their services. Now I'm going to go through the framework that I developed and follow to implement my idea. So here we have the stock market live or historic data. Use Polygon API to get in the ticker information. And then the sensor takes in that ticker information and sends it out as a CSV. It has the ticker, the opening price, closing price, the high and low. And then I also have windowing implemented. So the window is a time frame which I'm gathering my data. It can be 1 minute, 5 minute, 10 minute, 1 day, 10 days, over months even. And the data is a history of what happened in the market over a certain window. And then I have statistics like the sample mean that I can apply over this window and come up with summaries. So following this, I want some analysis to come up with models. And a model might take the average and see if the average over the window is increasing or decreasing, and then make a decision based on that. Based on the momentum, I want to make a decision on where the stock is going at some point in time in the future, and I want to have a visualization of the decision to the user so that they can either act on it or decide not to act on it. I went with, in order to make these decisions, I used quantitative finance and went with the standard crossovers. So quantitative finance is the use of large data sets and mathematical models to analyze financial markets. A simple moving average is an arithmetic moving average calculated by adding the recent prices and then dividing that figure by the number of time periods in the calculation average. The exponential moving average is a type of moving average that places a greater weight and significance on the most recent data points. Because of this, they are more reactive to the latest price changes than the SMAs are. But if you use them together, if you see the SMA go from above to below the EMA, that is a crossover indicating you to sell, and vice versa for buy. Now, for the purposes of the project, I used SMA 20 and EMA 50, which are common SMA and EMA values that traders use when dealing with stocks. So I'm going to show you some outputs from my program that I wrote. This window here is set to take ticker prices every hour. This went from February 16th to March 3rd. As you can see, just about here was when everything started happening with COVID, and there was a huge sell-off in the market. You can see that the SMA 20 fell below EMA 50, which sent the sell signal. And if you were to follow this, you would have been able to save your assets if you had a stake in this stock. And then once the recovery comes back around and you can see that SMA going above the EMA, it sends you the buy signal. Try to get back into it and make some profit. Another one here, this is SPY, around the same time when the market started going down due to everything that was happening with coronavirus and states and countries closing their borders from February 16th through February 24th. This is also during the 1 hour window, so it took the open price each hour for all those days. And you can see the buy signal here and then the sell signal here, which if you were to follow would have allowed you to get out before that huge market crash that many people were caught in and lost a lot of money. And here's a more recent one for Amazon. Now the window here is set to a 1 minute window from 9:30 a.m. to 2 p.m. This was on April 19th. You can see here you have a sell signal and then a buy, but then you don't really hold it that long because another sell signal comes along. So you can use it for short or long-term trading. As you see, I showed previously the sell signal where you were holding it for months, and this one is just in a span of some minutes. And then one last example here is a XSPA, where we have it for a full trading day, 9:30 a.m. to 4 p.m., where you have the buy and the sell signal, and then here a buy and a sell following the crossing over of the SMA and the EMA. So I have a demo that is recorded and it shows a mock-up of my app. And here we're gonna play it. My app mock-up, I wanted to keep it as simple as possible, going back to the earlier fact with people who were saying that the other apps had a high learning curve and it was difficult for them to navigate and use. So I'm going to go ahead and log in here. See, it takes me to the analysis page where this chart was generated by the Python program I wrote. And you can see that it has your buy signal when the SMA 20 crossed over the EMA 50, indicating a buy. And then when it fell back below, it sent a sell signal. We can click through, we're going to look at Shopify. We see a sell signal here at the beginning and the notifications here, and another buy and sell, and we have Slack as well. Same setup, sends you the notification. The time tells you whether to open or close a position, and it shows you the graph for you to be able to see it. And that is all. Thank you for listening, and I'll take any questions if you have them.
Thank you, Komlan. You know you're supposed to submit all these things to me, right? No, I'm just kidding. Any
I
questions?
have first dibs.
Any questions?
Are you planning to take it to the App Store?
I do want to continue it. I think I know the reason I don't have the app developer account is because I think they to put something in the App Store, I think you have to pay I think it's like $100 fee. But I would like to continue working on it, and I can at least download it on my own device without having to put it on the App Store, or if anybody wanted to download it, if I had their device, put it on their phone as well. But it is a possibility.
Thank you.
Okay, any other questions? All right, awesome. Thank you, Komlan.
Thank you.
Yeah. All right, so let me see here. I'm running